All right, so in this example, we're going to be determining how many zeros a function has by using the discriminant. So the function we're going to be doing this with is f of x is equal to x squared minus 9. So just as a quick refresh, what the discriminant is it's equal to b squared minus 4ac. And the way it works is that if it's greater than 0, we're going to have two solutions, that is two places at which this function intercepts the x-axis and equals 0. If the discriminant is equal to 0, we're only going to have one solution, one place where this function is equal to 0. And if the discriminant is less than 0, we're going to have no real solutions. There's going to be nowhere where this function equals 0. So let's go ahead and check the discriminant. Let's make a note that a is equal to 1. B, notice I don't have an x term. I have x squared, and then it jumps straight to my c term, which is negative 9. I don't have a b term, so that's going to be 0. Okay? Now, using the discriminant and plugging that in, we're going to have 0 squared minus 4 times 1 times negative 9. So the 0 drops out, and then negative 4 times negative 9 is going to give us a positive 36, which is indeed greater than 0. And so we're going to have two solutions for this function, two places where it equals 0. So we've done what the question asked. We've determined that there's two solutions. But let's go ahead and graph this just to get an idea for what's going on. So first of all, if I plug in 0 for x here, 0 squared is 0, and then I just get negative 9. And notice that for any other number I plug in, 1, for example, 1 minus 9 would be 8, 2 would be 2 squared, 4 minus 9 would be 5. It's never going to get smaller than negative 9. So that's my low point. That's my vertex. So if I graph this, when x equals 0, y equals negative 9. So if these are going by 2's, that would be like right here. And then, notice the discriminant doesn't tell us what the zeros are, just that there will be two of them. But if I look at x squared minus 9, that's a difference of squares. So I can rewrite this function as x minus 3 and x plus 3. So looking at that, my two zeros are negative 3 and positive 3. And I'll graph. So notice the discriminant told us that there should be two zeros, two places at which this function is equal to 0, and there they are right there. And you can see that it never happens before here because the graph just has this smooth sort of shape, and it never happens after here because we're told it just goes straight up like this. It's not going to like curve back down or anything. So there we go. Using the discriminant on this function tells us that it has two solutions for when it equals 0, and then just inspecting the function, we're able to graph it and verify that. And that is this example.